So hello amigos, today's lesson is on decision tree regressor or decision tree classification. Here I would like to ask you guys to emphasize more on the concept of decision trees more than this tree regressor or classifier. Yeah, let's get this straight. What is a decision tree classifier or regressor? So it's nothing but it's a machine learning model where you like to get some predictions. Obviously that's what machine learning all goes to, but here like what's going on in the background is wait, let me decrease the sound. Yeah, I think it's perfect. So I was saying uh, so all you need is certain rules. I will explain you in a very simple way. For instance, you want to know a person is successful or not. So first things first, you like to know whether he's determined or not. First, that's the first rule. Okay, so if he's not determined, then he's definitely gonna fail, right? Then okay, now he's determined. Okay, that's good. And then does he put the work? He's determined. Does he put the work or not? If he doesn't put the work, then it's a different situation. If he puts the work, okay, then that's good. Then does he have enough knowledge? So all these questions, like if you ask these certain questions and so on the fall on the like previous knowledge, you will come to know that whether the person is successful or not. if if he tick check marks all this, so all these check marks are nothing but set of rules. For instance, is determined or not, yes or no, it's a rule, right? So in the same way, uh, as I said, like how do we know these rules? We know it based on our knowledge, right? So here the problem statement is like whether the person is going to be successful or not. So I know the concept. So whereas coming to the data, first you need to find out the rules. So to find out the rules, you put these rules into the model. I mean, like you put the data into the model. The model will comes up with a set of questions, and then there you go, your model is trained and you have set of rules. And then you put some new data on it, test data, and you based on the rules, in the example which I told you, the similar way, some of the rules will come up and the test data will answer all those questions, and there you go, you'll get the answer whether it is a classification or regression. For instance, it's a classification, whether it is 0 or 1. So if we check marks all those, it is called uh, then the prediction happens. So that's the main concept of decision trees. Now coming to few keywords, and I would like to explain the math. Let's get into the board for nice and sweet explanation. So guys, coming to the mathematical intuition, in real world you will be given such kind of data set in front of you, where these are the features, feature 1, feature 2, feature 3, then this will be your target feature, where based on this you need to predict those. Based on this data, first things first, you will be creating a structure, or else in the other terms it also called as rules, which as I said in earlier. So let's I'll just show you a diagram of the rules. As I said, like first feature we took it as determined. If the guy is determined, then you'll go for the another check, which is like whether he works or not. So if he's not determined in the first place, then he is failed. So then coming to the second feature, then you evaluate work. Does he work, yes or no? If not no, then he's gonna be a failure in life. Then coming to the knowledge, so you check for the third feature, yes or no, and then that's how you come to a conclusion where he's successful. If he's knowledgeable, he puts the work and he's determined, then he is successful, or else like he's failure. So such kind of rules are they will derive based on the data. So how exactly we draw the structure? So there are a ton of decision tree algorithms where you put the data in, and in place you will get this set of rules. So to get these rules, there are few like terms to get to know before that. Let me introduce them. One is Gini index, entropy, which says you the purity and impurity of the split. So what exactly mean by pure split and impure split? Okay, let's get back here. So first things first, you took determined, and whether if he's determined yes, if he's not determined no, right? So okay, let's see about this. So if he's yes, work, right? So if he's determined, if he's determined, all these are determined ss. So there are two ss and one no, two ss and one no. Then coming to no, then there are only one no. So based on this, you can say there are no other, like no other choice than to get failure. So it means that this is a pure split, in the sense like if he's not determined, straight away no, there is no other option for him. So if he's yes, then two s's and one no of getting succeeded. Okay, so there is a bit of mix, right? Two s's and one no, there is a bit of impurity in this. So you need to come up with a numeric how impure is this split. Okay, and how pure is this split. Okay, so for that you need some metrics to do that. So one is Gini index, another is entropy. Let me introduce entropy first and we'll go to Gini index. Entropy is given by this formula, whereas probability of first class and probability of second class by multiplied by logarithm of probability base 2. Okay, so the similar way, okay, let me show you with the example here. 2 and 1, so 2 divided by 3. Okay, 2 divide, so you are calculating the purity of this. 2 divided by 3, and logarithm of 2 divided by 3 minus other class would be 1, right? You got 2 s's and 1 no in that split. So 1 by 3, and you might, if you do the math, you will get 0.4. And whereas the other one, uh, which is 1 no and 0 s, right? So yeah, so 1 by 1, I mean, like for this is positive class, for instance this is a positive class, then 0 by 1. And if it is negative class, then negative class 1 by 1, 1 by 2. Okay, so log 1 is 0, and here multiplied by 0, so it is 0, so it's gonna be 0. And here you're gonna get 0.4, something around that. So if you plot the graph, for entropy, this is entropy, the probabilities are 50-50, in the sense like half of them are, I mean, like it is not even providing any information, like half of them are ss, half of them are no. It means like it is very impure. You'll get entropy value of 0, I mean like entropy value of 1 if the probabilities of both the classes are 1 or either of them is 1. Then you get an entropy of 0. Okay, so entropy ranges from 0 to 1. If it is 0, then it is said to be pure split. If it is 1, it is said to be impure split. Okay, so in the similar way, Gini index formula is as simple as this. So one probability of positives whole square plus positives of negative whole square, and this, and then you substitute the probability values. Here let me take an example. Here you can see, so here you get probability of positives in this split is 2 by 3 whole square plus 1 by 3 whole square. So in a similar way you get something like this, but here in Gini index it is bit different than entropy. I mean, like the range differs. So the maximum value of Gini index is 0.5, that's to be noted, and entropy is 1, the same concept. So the I mean like uh, if the Guinea index value is 0, then it is said to be pure split. If it is 0.5, it is called impure split. When to use what is the next important interview question. So if you have a big data set, then always go with Gini index, because like there is no logarithm term here, so it is very computationally effective than entropy has logarithm in it in the computation, so it's gonna take time. So it all depends on what data set are you dealing with. So if you have a data set less than 10,000 records, then I would suggest you to use both of them and see which one is giving you better results. So that's pretty much a basic introduction of decision trees. I hope you guys liked it. So please let me know if you have any queries and reach out to me via LinkedIn, or like through by commenting down below your valuable like feedback or whatever queries you have on data science or statistics. I would love to clarify your doubts, and as well as if you want to collaborate with any kind of projects, etc., etc., please feel free to reach out. Thank you.